The notes for Unit 5, Lesson 1 will cover Avogadro's number. This comes from Chapter 10 in your textbook. You will want your yellow periodic table packet. In front of you, you will also want your notes packet to write down the information, and you will also want a scientific calculator of some sort so you can do the calculations. So first we're going to cover what is a mole. So a mole is a unit that we use in chemistry to group a very large quantity of particles. It could be atoms, molecules, basketballs, donuts, anything. So when we hear pair, we think of two, like a pair of socks we know is 2 socks. A dozen is 12. A ream of paper is 500. So these are common terms that go with specific numbers. The mole is the same thing. So if you have 1 mole, that means you have 6.02 times 10 to the 23rd particles. So like I said, it could be atoms, it could be molecules, it could be basketballs, it could be calculators, anything. 1 mole of anything is 6.02 times 10 to the 23rd. So here's the hard thing with the mole. That number is huge. So when you have times 10 to the 23rd, that means that you take the decimal and you move it to the right 23 places. So if you wrote out the value for 1 mole, it would look like this, which is a ridiculously large number. But if you think of it, atoms and molecules are really, really small, so there has to be a lot of them when you're talking about a mole. So instead of always repeating 6.02 times 10 to the 23rd, we just say you have 1 mole of substance, or you have 0.5 of a mole, or you have 4 moles. So it's a lot easier to quantify such a big number. This is just kind of a random fun fact with the mole. So again, the mole is this ridiculously large number of particles. So Jeff Bezos, who is the creator of Amazon, is the wealthiest person in the world. His net worth is $145.1 billion currently. He is projected to be the world's first trillionaire by 2026. Anyway, so if you consider this much money, which is a crazy amount, it is only a small fraction of a mole. So I found a little fact online. If you had 1 mole of pennies and you gave away $1 million every day to everyone in the world, it would take you more than 3,000 years to distribute all your money. So a mole is like this crazy, unfathomable, large number that we use in chemistry. So here we go with notes. So the mole is a unit used in chemistry to describe the number of particles in a substance. So we use the mole kind of like we would use the term dozen. Avogadro's number, so Avogadro is the scientist that is credited with this number. His number is 6.02 times 10 to the 23rd, which could be atoms, it could be particles, it could be molecules. So scientists use the mole to group this huge number of particles into a simpler quantity. So the conversion factor to convert between particles and the mole is this. So for every 1 mole is equal to 6.02 times 10 to the 23rd particles. And like we said, those particles could be atoms, molecules, pencils, basketballs, anything that you're referring to. So in your yellow packet, you have this mole map towards the back. I believe it's the very last printed page. So this is the mole map that we kind of use for a roadmap to do these mole conversions. So this first week, we are only going to stick to side A of the mole map, and then later we'll switch from side A to side B. But these are the conversion factors that we will use to go from moles to atoms or moles to grams. So you'll use this table quite a bit. The only conversion factor that you are doing for less than 1 is from moles to particles. So here's our Avogadro's number. Here's your 6.02 times 10 to the 23rd molecules or particles is equal to a mole. All right, so if you have this calculator, the easiest way to do it is if you type in 6.02 and then you type in the second key and the double E key, which is the same as the comma, and then you type in 23. So 23 is your exponent. The calculator will display this number. If you use this method, you don't ever have to worry about parentheses. Your calculator knows that that's all one number. Keep in mind, if you are used to using the 10 to the x button, which is here, then you really have to be careful with parentheses. So we'll do some practice with your calculator. If you have a calculator like this, if it has an EXP button, then this is how you would type in your exponent. So again, if you use the 10 to the x button, you just have to be really careful about using parentheses. So if you use 10 to the x, you'd have to do parentheses 6.02 times 10 to the 23rd, and then end parentheses before you enter the next value. All right, so here are 2 mole conversions that you can add to your notes. Again, we are just on side A of the mole map, and actually we are just in this little section going between moles and particles for now. So when you set up your conversion, first you want to know how many moles. So I put a question mark, moles, and then I set up a conversion chart like this because we need to have one unit cancel out. So this is how we set up our conversion. All right, so the number given in the problem is 1.50 times 10 to the 23rd molecules. Yikes, I should have made that a little bigger. So because we're starting with molecules up top, we need molecules to cancel out. So molecules is going to go on the bottom of the next step. From our conversion factor, which is here in the middle of the mole map, we know that there are 6.02 times 10 to the 23rd molecules equal to 1 mole. Yikes, sorry, my writing is not very clear. So molecules cancels out, and we are left with moles, which is what we're trying to find. So when you have your conversion set up, this bottom space is always going to be empty. The conversion factor between 1 mole and 6.02, this step, these are equal values. So when you have equal values, one is going to go on the top and one is going to go on the bottom. The reason why this first space is empty is because we don't know what 1.5 times 10 to the 23rd molecules is equal to. That's our unknown. That's what we're trying to find. So that first part always stays blank on the bottom. And then what you do is you're going to multiply the numbers across the top and divide by the numbers along the bottom. So you would type into your calculator 1.5 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and then you have to round to sig figs. The only number in the problem has 3 significant figures. So our final answer would be 0.249 moles. All right, to the second example, we want to know how many atoms. So question mark atoms goes here. And then we'll set up our conversion factor. So we're going to start with the only number in the problem, and we have to label everything. So it's super important that you label all your numbers, because if we start with moles, we know moles has to go on the bottom of the next step to get it to cancel out. So we're going from moles to atoms. So we're going from moles to atoms. So on our mole map, we are using moles to atoms. We know that in 1 mole, oops, sorry, my pen turned off. We know that in 1 mole, there are 6.02 times 10 to the 23rd atoms. So again, these are equal values. Moles has to cancel out. So if we start with moles, then 1 mole would have to go on the bottom. And then to solve this, you would multiply the numbers across the top and you would divide by the numbers along the bottom. So we're going to take 1.75 times 6.02 times 10 to the 23rd divided by 1. Our number in the problem has 3 sig figs, so we're going to end up with 1.05, and then we have times 10 to the 23rd, or sorry, 10 to the 24th is an exponent. Sorry, I kind of ran out of space here. So my answer, I'll rewrite it down here at the bottom, would be 1.05 times 10 to the 24th atoms. It's super important that you add the times 10 to the 24th because that is part of the number. So that shows us that there are 22 zeros onto the end of this number. So that means it's a really, really huge number. Hopefully this helps. We will go over lots of mole conversions throughout this week.